Welcome, students, to Political Science 370, Social Science Research Methods. Again, today we will be looking at a journal article that was selected by Jillian Betts. She wasn't scheduled to go until much later in the semester, but she got it done early, and now's a good time to take a look at it and have it available, so I decided to do that. So, the title of the article is The Accuracy of Citizen Science Data, a Quantitative Review. And it was conducted by a number of researchers at the Bren School of Environmental Science and Management at University of California, Santa Barbara. Hey, now, Michael.
Yeah.
Again, since you're the only person in the class, you're going to have to do the heavy lifting when it comes to student participation. If you were an environmentalist, right? If you were an environmental studies or an environmental science professor, why would you want to use data gathered by citizens rather than scientists?
Oh, because sometimes scientists could be influenced by corporations, I guess.
Oh, good point. Maybe corporations
I'm trying to think.
are donating?
I don't know. I guess people are outside more than most scientists.
Well, yeah, see, that's the thing, right? If I'm teaching at UCSB in the environmental science or environmental studies program, do I probably believe in global warming?
Yeah.
Am I being a little hypocritical if I fly down to the Amazon rainforest in Brazil to study the effects of global warming?
Yeah.
Why?
The jet fuel, I guess.
Yeah, well, exactly. Airline travel leads to a lot of global warming, right?
Yeah.
If citizen science data is accurate, then it allows us to gather data over large spatial distances, and it also allows us to gather data across long periods of time, longer than any one researcher can live, if citizen scientists are gathering it systematically over a lot of time, right? Do you think, especially in people that are in environmental studies, do you think they want citizen science data to be accurate?
Yeah.
Yes, they're kind of rooting for it, right? Okay, so these researchers say there have been a lot of qualitative studies done that look at the accuracy of citizen science data, but we're going to try to find as much quantitative data out there that we can and gather it all together and see how much of it finds that citizen science data is generally accurate and how much of it finds that citizen science data is generally inaccurate. So this is a study of a lot of the studies that look at the accuracy of citizen science data. So what do we call a study like this?
Meta-analysis.
A meta-analysis. Outstanding. So this is a meta-analysis. And they start by saying we used a snowball approach to find studies published before 2014 that compare citizen science data with some sort of reference data, accurate data, data gathered by scientists, right? So they start with one article by Danielson et al., and that article cited 16 others that looked at the quality of citizen science data. And so then they did a search on Google Scholar to see what other articles had cited those articles, right? And so you start with the one article, it cites others, they cite others, they cite others, and it snowballs. Make sense? Mm-hmm. So then they wind up with 72 articles, and they had to exclude 9 of those for reasons they explain in the article. They're too technical. I don't want to deal with them now. And so they wind up with 63 studies. But the studies had a lot of comparisons within them, right? So it's not like each of these 63 articles only looked at one data set or something like that. You know, they looked at a number of data sets. And so they said for each of the 63 papers, we identified each comparison between citizen scientists and professionals that was made, and this yielded 1,363 comparisons. Is that a good amount of data?
Yeah.
Yeah. So a good sample size there, which spanned a wide range of measurements from identification of counts of specific species to calculation of total nitrogen concentration in the water, right? They ranged kind of widely, the things that citizens were asked to measure. Water quality, you count species, that type of thing. Now, on a brief side note, my brother-in-law is a marine biologist. We visited him. And when we got to this point of the article, it kind of got me thinking. He took us out one day to go look at things at low tide, right? So these are areas that'd be covered with water when the tide is high, but they're exposed when the tide is low, right? Isn't that the intertidal zone?
Yeah, I think so.
Yeah, I think so as well. And we went out there, and with no training at all, how many species do you think you would have been able to find?
None.
None. But once he took us out there, he started turning over rocks, right? And things like that. And how many species were you finding?
Oh, hundreds.
Yeah, it was unreal, right? Like, we went out there totally untrained. We're like, all I see are a bunch of rocks, right?
Yeah.
But he started flipping them over. He's like, no, they hide under the rocks, so you got to find all these different types of animals that lived in that area under the rocks. Blennies, weren't some of them called blennies or something like that? So, I mean, just all these different species once you knew where and how to look for them, right? So with a little training, you would do a lot better, right? So that's one of the things that they looked at was, whether the citizen scientists had received some training or not, right? Okay, so that's basically how they obtained their data set. And then they looked, and they provided characteristics of the data. At first, this is one of the most confusing charts I've seen in my life, right? But then afterwards, it wasn't so bad. Basically, if you look down here, they just said, what type of environment are they looking at? Terrestrial, freshwater, or marine. Make sense?
Sure.
And so the bigger it is, the more terrestrial studies were conducted.
Yeah.
Make sense? And then it flows, and then it's like, how long was the data gathered for? The most common was 0 to 1 month, right? Then 2 to 6 months, 7 months, longer than that. B and C, most of them were pretty short, that 0 to 1 month time.
Oh.
Yeah. Why do you think most of the studies were conducted over 1 month or less?
You probably can't hold interest that long.
Yeah, it's just hard. Yeah, and not just citizens, researchers, right?
Yeah.
To conduct really longitudinal studies. Then the next bar here was just how many people gathered the data. 0 to 10 people, 11 to 50, 51 to 100. And then the last was training versus no training. And so if you swoop through all of them, you can find out terrestrial, 0 to 1 months, this many people, and this many had training,
Okay.
Yeah, it's crazy. But the main things that they care about are what were the types of environment, terrestrial, freshwater, or marine. How long were the studies conducted over? 0 to 1 month, 2 to 6 months, some months to a year, 1 year to 5 years are not applicable. How many people were involved in the data collection? 1 to 10, 11 to 50, 51 to 100, and on. And whether the people received training or no training. Right?
Mm-hmm.
Okay, so that's that table. Then this was kind of a tricky little test, which I'll just so briefly, but just so you know, they looked at all these different types of studies, and then what kind of statistical test that was done to compare the quality of citizen science data to the reference data or the scientist collected data, right? Because there's different statistical tests depending upon the type of research that was conducted and the type of data that you have, right? So they looked at what statistical tests were done or what comparisons were done, because in some they couldn't even do statistical tests. They just said, well, in this situation, the scientists found 81% of the people had this, and then the citizen scientists had such and such an agreement with it, and they gave it in terms of a percentage agreement without there being a hypothesis test possible. So anyway, the point is, as they looked at all these different studies, these studies tried to compare the accuracy of the citizen science data to the accuracy of the reference data, or the data that was gathered by scientists. And the authors of the article we're looking at right now told you all the different statistical approaches that were used to try to see if there's a difference between the citizen science data and the reference data. Make sense?
Mm-hmm.
Okay, so they went through, and to make a long story short, you have a lot of stuff going on,
Mm-hmm.
but then finally they get to the meat of it,
Okay.
which is what helps us predict how accurate the data is going to be, right? So this, not to be mean or anything, but this was one of the worst tables. I think I've seen. Remember I told you how tables are supposed to be able to stand on their own, right? In this situation, they didn't really label the dependent variable, so I did it for them, which is, I know, which is accuracy. Accuracy of the data, right? So that's on the dependent variable. Accuracy. Goes from low to high. And again, not to be mean or anything, but the researchers, I felt, could have done a better job helping the reader know what the dependent variable was.
Yeah.
They also, I think, could have done a better job letting them know what statistical approach they were doing. They said they're using a form of linear regression analysis, but they don't know what type, or they don't specify what type. Yeah, I mean, I'm sure they know, but they don't clearly specify what type, so I assume it's OLS.
Yeah.
Right? And so they present the data here.
So you had to put their stars on there as well?
Yeah, I did, because they only did the coefficient estimate, and then they had coefficient way over here instead of next to estimate. I don't know why, but these are their independent variables. These are their independent variables, right? And it's hard to get the whole thing on here. Okay, but Michael, accuracy is the dependent variable.
Okay.
So, compared to a freshwater environment, when is citizen science data more accurate? In a marine and a terrestrial environment or not?
It looks like it's more accurate in marine and terrestrial environment.
Yes, exactly, because freshwater is your omitted category. That's your reference category, right? And so you look, the estimate is many times as standard error for both. So they're both statistically significant. So if you were a researcher, where would you have citizen scientists collect data? In a freshwater environment or a marine and terrestrial?
Marine and terrestrial.
Exactly. Next, participation length. So 0 to 6 months, or 7 months to a year. Over time, 7 months to a year, does the data get more accurate or less accurate?
More accurate.
More accurate, exactly. Positive coefficient estimate. It's right on the borderline of statistical significance. You see the p-value there?
Yeah.
0.057. So it's super close. But yeah, it looks like the longer they participate, in general, that's better. But then there's monitoring frequency. Repeated. So you gotta go back to the same site over and over again, right? The more times you have to go back to a site, what happens to the accuracy of the data?
It decreases.
It decreases. Why do you suppose that is?
Burnout.
Burnout, exactly. That'd be my guess. Is people have stuff that comes up. They may just start making up the data. Who knows, right? But you'd assume they'd get better at it the more they do it,
yeah,
right?
It would.
But I think it's probably just burnout. You know. The next ones aren't statistically significant. Group size. Training. If citizen scientist receives training, what happens to the accuracy of the data?
It gets better, increases.
It gets better, increases, exactly. And then this volunteer type is tricky. You have to read the article. I did. So The omitted category, the reference category, is if you have some kind of physical or financial stake in the outcome. For example, you collect mussels along the shore, and there's a possibility they could be getting contaminated by an oil spill.
Oh.
Right? So you have some type of stake in the outcome. If you have some type of stake in the outcome, do you think you're probably going to care more and gather more accurate data? Yes. Compared to a volunteer. So if you are just a straight up volunteer, no stake at all in the outcome, what happens to the accuracy of the data you collect?
It decreases.
It decreases, exactly, compared to a volunteer that has some sort of stake in the outcome.
Yeah.
Right? Then specialized knowledge, some type of specialized knowledge. Yes. Does that increase or reduce the accuracy of the data?
Increased accuracy.
Increases the accuracy of the data. Yep. And the adjusted R-square, you're explaining about 20% of the variation in data accuracy. So, yeah, they didn't put stars in there for you. They just did p-values and they did the e exponential thing. Whatever. They weren't making it easy on you. Yeah. But anyway, so as you look at that, this is kind of a good contribution to the research.
Yeah.
Because it suggests, looks like in certain types of setting, research citizen scientists gather more accurate data than others. Marine and terrestrial, they do all right. Looks like they struggle in freshwater. I don't know why. If you participate longer, it gets a little better. Don't burn your volunteers out by making them monitor too frequently. Provide them good training, and hopefully find volunteers that have a stake in the outcome and some type of specialized knowledge. So that's the main contribution. Now, what do you think of the paper so far? Good paper, bad paper?
I think it's good.
Yeah, overall it's a good paper. I have... So how would you summarize the paper in your own words?
Well, they were finding what would make citizen gathered data more accurate. And it was all that stuff we went over.
Okay, very good, very good. And then they also looked at the number of times, and is that all you got out of it?
I guess.
Okay, all right. Then we missed the next big point. The next big point was when they were looking at all those studies, they tried to determine whether there was a statistically significant difference between the citizen science data and the reference data or the science gathered data. See, now this, in my opinion, was the most problematic part of the study. Okay, so let's kind of go back to just kind of like fundamental research question, right? Okay. When we're doing an experiment, do we compare the treatment group to the control group?
Yes.
Yes, right? So, at the end of the day, that's also what they're doing here, is they're comparing two groups, right? The citizen science data, the data that's gathered by citizen scientists, and the data that's gathered by the pros, right? Real scientists. It's their job. The reference data. Right? Okay, well, knowing what we know about the effect of sample size, if you have a really large sample size, is there going to be a statistically significant difference between the citizen science data and the scientist data?
Yes.
Yes. Why?
Just because it reduces the standard error so much, those big groups, yeah.
Exactly. And so, one of the ironic things about this is if you had a really well done study comparing the effect of citizen science data to scientist data, and you had a huge sample size, are you going to find a statistically significant difference between the two groups?
Yes.
Yes. And so, in the journal article Jillian selected here, in their data set, that study would actually be used as an indication that the citizen science data was flawed. Make sense?
Yeah.
Because they only look at statistical significance, not substantive significance. Make sense?
Yeah.
Okay, so again, since it's methods, a lot of research designs that use experiments look at the treatment group, the control group. If your sample size is large enough, if it's big enough, will there almost always be a statistically significant difference between the two groups?
Yeah.
Yes. So especially when you have a large sample size, what's your responsibility as a researcher or a reader at that point?
Determining substantive significance, yeah.
Exactly. Determine the substantive significance.
Yeah.
And they didn't necessarily do that. Make sense?
Mm-hmm.
Okay, now again, imagine that they, instead of a treatment group and a control group, citizen science data, scientist data, imagine that the research design is a little different and they're looking at the accuracy of data that's collected. Assume they're using like OLS,
Yeah.
right? And they're looking at the accuracy of the data that's collected. And they look at different environments, like marine and terrestrial versus freshwater, right? Mm-hmm. They have all the usual suspects that in the literature, right? So what affects the accuracy of the data? What affects the accuracy of the data? The type of environment that is gathered in, whether people have specialized knowledge or not, blah, 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 all the things, right? Then you have a dummy variable where scientists gathered data scientist is the reference category. It's the omitted category.
Yeah.
And volunteer citizen scientist is the dummy variable. Coded 1 if the data was gathered by a volunteer, and citizen scientist 0 if it's gathered by a scientist. Make sense?
Yeah.
Does this research design make sense? This is just OLS, right? With a number of control variables, but then the comparison group, right, is citizen scientist versus scientist. If my sample size is large enough, will the citizen scientist variable come back statistically significant?
Yeah.
Absolutely. Why?
Just because such big sample size, yeah.
Just because it's such a big sample size. Again, outstanding, right? Yeah. So it's up to me as a researcher to interpret the substantive impact or the substantive difference in the accuracy between the citizen science data and the scientists gathered data.
Hmm.
Make sense?
Yeah.
Yeah. So, that is my main concern with the study is when they were looking at all of these other studies, all they looked at was if there was, well, in the studies that where there was hypothesis testing, where they even had statistical approaches. They just looked at whether there was statistical significance, not necessarily substantive significance, and you're in essence penalizing researchers who had a large data set.
Oh.
Yeah. Any other questions, comments,
No, I don't
concerns?
think so.
All right. Well, just want to tell Jillian, outstanding job critiquing that. Overall, you guys have been doing a great job on your papers. Keep up the good work. And my son has organized these under a playlist on YouTube on his network, Buns Network. So you can go to that playlist and find all the videos that I've been uploading on that discuss methods. I've only had one that did methods in general so far. All the others basically have been presentations on the articles you've selected. So go to the playlist and find all the methods ones. Take care. Buns Network.